In this video, we'll review how to find the area of both circles and sectors. To begin, let's start with some circle vocabulary. A circle is the set of all points the same distance from a fixed point. In this case, the point G, if we take a certain distance and we take all the points that are the same distance from G, we get what we call circle G. The way we name it is that circle symbol. The capital letter becomes the center of the circle, so this is circle G with the center at G. The radius is something we'll often look at for circles. The radius is the distance from the center to any point on the circle. Now the distance from that center point to any point on the circle will be the same no matter where we take it on the circle. So the radius from G to that point there would be the same as from G to any other point on the circle. As a justification, we'll say all radii are equal. Now another term we're going to look at is diameter. The diameter is any segment that goes through the center with both endpoints on the circle. Now the diameter is a special type of chord. A chord is a segment with endpoints on the circle. The difference is this chord has to go through the center. Now the diameter will always be twice the radius. Or thought otherwise, the radius is always half the diameter. So when we're solving problems, if we're given diameter and need radius, we'll cut the diameter in half. However, if we have the radius and we want the diameter, we'll double it. To find the area of a circle, we're going to use the formula pi r squared. The area of a circle is the region inside of a circle. Area is a region. It's a two-dimensional space, measurement. So that two-dimensional measurement we call the region. The formula is pi r squared. So if we know the radius, we'll square it and then multiply by pi. When you do these kind of problems, you want to make sure you give both an exact and an approximate answer. The exact answer will still have pi in it. The approximation will use the calculator and find an approximation to it. So let's look at a couple examples of how to find areas of circles. To begin, we're told we want to find the area of a circle with a radius of 6 inches. So in this problem, we see that we have a radius of 6 inches. So we're ready to substitute. The area of a circle from the last slide is pi r squared. So we'll simply substitute in that 6 and say area equals pi 6 squared. Working this out, 6 squared is 36, so we get 36 pi measured in inches squared. Now remember, an area is a two-dimensional measurement. It needs to be something squared. To find the approximation for this, we'll take our calculator and we'll type in 36 times pi. Please, again, don't use 3.14. You'll probably pick up a little bit of a rounding error. Use the pi button because it's more exact. If we type in 36 pi, we find that it's about 113.10 inches squared. Now take a look at the next problem. In the next problem, something's a little bit different. See if you can figure it out. Alright, hopefully you came up with this time. Instead of having the radius, we have the diameter. There is not an area formula that uses diameter. So to begin, we're going to have to take that diameter and use it to find the radius. Think back to how we're going to do this. I know the diameter is twice the radius. So if the diameter is 2.5, and I cut that in half, that'll give me my radius. My radius is 1.25, or 1 1/4 inches. I can now substitute into the area formula pi r squared. 1.25 squared is exactly 1.5625, so that would be my exact answer. It's 1.5625 pi inches squared. I'll then take my calculator and approximate. And it's going to be about 4.91 inches. Now when we round, we want to round to the nearest 100th. That would be 2 decimal points after the 2 decimals after the 0. And again, we want to make sure that when we do area problems, we're getting both the exact and the approximate. All right, take a look at the last problem and see what's different now. In this case, we're not told the diameter and we're not told the radius. Instead, we're told we want to find the area of a circle where the circumference is 24 pi inches. To do this, we're going to begin with the circumference formula to find the radius, and then once we have the radius, we'll use that to find the area. So this is going to be a multi-step problem. Now I know I need the radius when I find area, so I might as well use the circumference formula that has radius. Or I can use the one that's pi d. If I use pi d, it's a little bit easier to see this one because I can just divide by pi, and I get the diameter is 24. Now if I do this, I still have to divide by 2 in order to be able to actually find my radius. So if I take the 24 divided by 2, I get the radius is 12. Now, it might have been simpler to say that the circumference was 2 pi r. in which case I could have divided by 2 pi, and I would have straight gone to the radius is 12 inches. Either way, we still get the same answer. Now I'm going to take that 12 inches and I'm going to plug it into the area formula. Area equals pi r squared, so therefore the area becomes pi 12 squared. 12 squared is 144, so I get that the area is 144 pi inches squared. Now that's my exact answer. To approximate, we'll use the calculator and we'll type in 144 times pi. And that's going to be about 452.39 inches squared. Now the next piece is sectors. So now that we know how to do the area of a circle, we can use that to find the area of a sector. Here's a picture of a sector. This is sector AOB. A sector is basically a piece of a circle. And it's going to be formed by 2 radii of a central angle and the arc between their endpoints. So in this case, we're talking the 2 radii, AO and BO, and the arc AB. This forms a slice of the circle, and we call that a sector. In order to find the area of a sector, we're going to take a piece of the circle, the angle that we're given, and we're going to multiply by the area formula, pi r squared. So in this case, the area of sector AOB would be whatever measure of the arc we have out of 360, because that's going to be the piece of the circle, times the area of a circle, pi r squared. Now instead of using arc AB, you can also use the central angle. So if you're given the central angle, you can go straight to that angle over 360 times pi r squared. Or if you're given the arc, you can say it's the measure of the arc over 360 times pi r squared also. So let's look at one example of how to do this. In this case, we want to find the sector of AOB. We have the measure of arc AB is 36 degrees, and we're told that the radius is 10 units. So let's put this together. We know that we have 36 degrees out of a full circle. A full circle is 360. So when we set this up, we're going to say the area of that sector is the 36 degrees that the arc measures over the 360 times the area of the circle. Now in this case, we have a radius of 10, so that's going to be pi 10 squared. Now if you're wondering where that 1/10 came from, is I reduced the 36 over 360. I can divide top and bottom by 36. 36 goes into 36 once. 36 goes into 360 10 times. So I get 1/10 times the pi r squared, which in this case is 10 squared pi. 10 squared is 100, so I get 100 divided by 10. 100 divided by 10, or 1/10 times 100, is just 10 pi. Now this is an area, so it needs to be a square unit. We don't know what we're measuring. It doesn't say inches or meters, so we'll just say units squared. Now, like in the previous problems, we want to give the answer in 2 ways. This is the exact answer, and when we use the calculator, this would be the approximation. So again, the steps. We take the piece out of 360, and that piece is measured by either the arc or the central angle, and then times the pi r squared, which is the area of the circle. We work the fraction out, reduce it, get the exact answer, and then approximate. All right, I hope this helps you, and thank you for watching.